Okay. Then last time we were doing something, SAT practice something.
Yeah.
Were we doing it from my laptop or did I find something on?
It, it was from your laptop.
Really?
Yeah.
Let me check it. Okay, so let me share. Yeah, so I think you can see my screen right now. By the way, you are being recorded here on in this, and I will upload it to the
Yeah.
YouTube as well. Okay.
Okay.
Okay. Thank you. Because I think the lesson we are doing might help another student. That's why. So let me check it. Documents, ACT exam. Yeah. SAT practice. Oh yes. Oh, even it brought us where we left, right?
Yeah.
So we solved, I think, question number 14, and now we need to continue 15, I guess.
Yeah. Yeah.
Okay. So bacteria are growing, blah blah blah. Let's do it together. Can you see it, or do I need to? Yeah.
I can see it.
Okay.
Okay, I need a notebook and paper.
Mm-hmm.
Okay.
You are solving on your notebook?
Yeah, but can I see the problem, please?
Oh, yeah, for sure. Sorry. So what's your thought process? How are you going to do it? Like, so let's see if you are on the right path.
I'm
So 300,000, and after 3 hours, how many?
it doubles. So
Doubles.
like
Yeah, exactly.
600,000, right?
Exactly. So after 15 hours, what are you going to do? Like, so how many threes in 15?
5.
5, yeah. So
Yeah.
do we need to multiply it by 5, making the answer A?
No.
Very good, thank you. A is wrong answer.
Would there be like an equation for this? Because I think there might be, but I'm not sure.
Yeah, kinda, but
Like,
so let's improve something together. So whiteboard Microsoft. Yeah, let me open this one. Yeah, one of them I did with you, I think. I'm not sure which one. Let me erase it. Let me erase this one as well. And maybe erase it as well. Okay. So we are starting with x, right? Let's say
Yeah.
that's our beginning, and then let's say after every 3 hours it doubles. Okay, for every 3 hours, 3 hour, it doubles. So let's say 2. We need to multiply it by 2 for each 3 hours. Yeah, so 2x, and then again after 6 hours we need to multiply it by 2 again, right?
Yeah.
After 9 hours,
2.
2 again. So for each 3 we are multiplying it by 2, 2, 2. It continues like that, right?
Yeah.
And I don't know if you have seen, like, if there are n, like 3, how many 2's you see here?
3.
3 of them. I don't know if you have studied exponential, but we are going to use exponential here. So is it 2 multiplied by 3, or is it 2, I don't know, 2 to the power of 3? What do you call that in America?
Yeah, 2 to the power of 3. Would it be 2 to the power of 5?
Yeah, exactly. That's why I'm calling you intelligent student.
Thank you.
You really are very intelligent. So can you go on the rest by yourself? So I'm going to share the link with you here. Copy link, and I'm
okay.
Because if I solve it, the rest it would be I am solving it. So I want you. By the way, last time your mom said that you were ill. Are you okay now? Are you good now?
Oh yeah. I was I was like a bit sick, so.
Okay.
But I'm okay now.
That's good. You can click on this link, and
Yeah, I got it.
and start doing the rest. So meanwhile you come, let me write some few things here. So it's like n times. So it means like n
Okay.
n times. So if there are 3 of them, then we are going to make it 2 to the power of 3. If there are 5 of them, 2 to the power of 5. If there are n of them, it means 2 to the power of n. Yes. So we are going to basically multiply with that at the end. Can you do the rest of the solution, please? So this is a number at the beginning. Number. That's x.
Okay.
Go on.
So x would be like the 300,000 doubled, right?
300,000 doubled, but after 3 hours. But what about after 15 hours?
Oh, okay. Oh, okay. So that would be like the x would be the result. Okay.
Yeah, x would be multiplied by what? So how many 2's are we going to see there? So how many 3-hour slices do we have in 15 hour?
5.
Exactly. So there are going to be 5 2's. Yeah. Can you continue to write down 2 more? Can you add 2 more 2's below here?
Where?
Can you see the?
No, I can't.
You can't see what we are writing here?
Oh, right there. Now I can.
Yeah, so can you write
Wait,
down, if I added fourth 2, can you write down the fifth 2
Oh, yeah.
below, please?
Yeah.
Yes, thank you. Good. So if how many 2's do we have?
5.
5. It means like making doubling it 5 times. So it means x is multiplied by 2 to the power of 5. Yes?
Oh, okay.
Yeah, isn't it like that? Because like we are doubling it 5 times, right? Okay, so each time like doubling, multiplying by 2, 2, 2, 2, 2. So n times, it means 2 to the power of n. 5 times, it means 2 to the power of 5. So what is 2 to the power of 5? 10?
2 to the power. No.
Very good. Thank you. I built trap and she knows traps must be avoided. Good.
Would it be... Wait.
Let me help you. So this is 2. This 4. This 6.
Wait, what?
So so 2 to the power of 1 is 2, right?
Yeah.
Let me help you. 2 to the power of 1. First time we are multiplying, doubling it. It means 2. We double it twice. It means 2 to the power of 2. It is 4, right?
Yeah.
And we are doubling it third time. 2 to the power of 3. It is 6, right?
Yeah.
Doubling. So 2 multiplied by 2 makes 4. Okay? 2 multiplied by 2 makes 4. So 4 multiplied by 2 makes
8.
exactly. I built a trap there,
Okay.
and for the first time,
Oh, okay.
Natalie,
I was like confused. I was like, wait, what?
Natalie fell for the trap. You see, so it means 2 multiplied by 2 multiplied by 2. Okay?
Yeah.
So 2 to the power of 4, 8.
So it would be 8 times 8.
64.
64, yeah.
Right?
Yep.
Yeah, I continuously build traps, and for now she keeps uh, getting trapped. So it means 4 2's multiplied by each other. So multiply it. What you get? 64?
Wait, so we're doing 64 times 64, right?
No. So
Wait.
so it 2 to the power of 1 means you just have 1 2. That's it. That's here. And 2 to the power of 2 means 4, because you are multiplying 2. You have 2 2's. You multiply it by each other. 2 to the power of 3 means 8, because 3 2's multiplied by each other. So 2 multiplied by 2, it means 4. Just look at the prior number. So 2 to the power of 2 is 4. So you multiply it by 2, you get 8. So 2 to the power of 4, just prior, 2 to the power of 3, that's 8. You multiply it by 2, you get
16.
Exactly. Like basic calculation. Now you do 2 to the power of 5. While you are doing it, you need to explain. Write down below, please.
Okay. 2 to the power of 5 2 times.
equals to 10.
32.
No, that's good. Okay, this time you didn't fall on my trap. So it means the number beginning should be multiplied how many times?
2.
2 to the power of 5.
Wait, no. Oh, no, wait. The number multiply. Oh, by 32?
Exactly, that's what I'm expecting. The beginning number should be multiplied by 32. Okay?
Yeah.
And what's the beginning number?
300,000.
Yes, now do the calculation part, please. 300,000 multiplied by 32.
Okay.
Mm-hmm. Did you find something useful?
It would be 96. No, 900. Wait, let me write it down. 960,000.
That's like triple of 300,000.
Wait.
You sure it's a 900?
Oh, my bad. My bad. I forgot to add a 0. It's what's it called? It's 9,600,000.
Exactly. So the answer is?
Yeah, there you go. 9,600,000.
Answer is delta, right?
Oh yeah.
Can you write down 15 delta? We'll check at the end.
Yeah.
Okay, good. Question number 16.
Oh, okay. I could probably do that.
So we need to, I don't know, what do you call it? Simplifying?
Yeah. Yeah. Like simplifying the expression.
Okay. Were you able to solve it? Are you solving it? So let's write down the expression here first. Let's write down the expression where to our side first. So I'm clearing the canvas here. Yeah. So I'm telling you the expression and you write it here, okay? 6x to the power of 8, y to the power of 2.
6x.
So,
Oops, that's a bad 8.
yeah, 6 multiplied by x to the power of 8 multiplied by y to the power of 2. Plus 12 12 multiplied by x to the power of 2 multiplied by y to the power of 2.
Okay.
Yeah, let's simplify it. Good. X to the power of 8. Yeah, good. Let's simplify it. So we are starting to simplify by the lowest number, yeah?
Uh-huh.
or what do you call that? Greatest common multiple or lowest? No, that's GCM, yeah? Greatest common multiple? Am I saying it right?
Yeah.
Okay, so
Yeah.
6 and 12, they have the greatest. What's their greatest common multiple?
6 is 12.
3?
Oh, greatest common the 3. No.
Because we have 3 in each of those numbers, right? 6
Yeah.
is 3 multiplied by
3.
2, 12 is 3 multiplied by 4, right?
Yeah.
Okay, that's good. So let's go on and write 3, correct?
Yeah. Okay.
But
3.
hold on.
Where do I write it?
But before writing that, we need to pay attention. So okay, let's go on to writing that, but I will help you with another thing. So yeah, we can write 3, but there is one more thing. So but hold on, like 6 is, so we can say it's like when looking at 6, 3 multiplied by 2, that's good. Also we have 6 multiplied by 1, right? And 12, let's simplify that. 3 multiplied by 4 and 6 multiplied by 2 and 12 multiplied by 1. And yeah, and now we need to find the largest number that each of them has. Both of them has. Which is the largest number?
6.
Exactly. 6, okay? So it means we need to take 6 as the simplification, I don't know. And then for x, now we come to the x. So which is the lowest? Like we need to look at the power, right? So here we have the power 8 and here we have the power 2. So we need to take the lowest power, right? Okay, so it means 6 multiplied by x to the power. Do you know how to simplify that?
1.
X to the power of 1?
No, it can't be.
Okay, let me help you with that.
Is it? I can't.
So it's like before, something similar to that. So this is, we can say x to the power of 7, x to the power of 1, x to the power of 6, x to the power of 2. It goes on like that. Let me continue. So x to the power of 6, x to the power of 2, x to the power of 5, x to the power of 3. It goes on like that, okay? X to the power of 5, and then x to the power of 3, x to the power of 4, x to the power of 4. And then it's like reverse, or so basically after that we again write x to the power of 3 and x to the power of 5. So it reverses kinda, so we don't need to write the rest. Okay, and now let's write here x to the power of 2, x to the power of 2, x to the power of 2 and x to the power of 0. It means 1, okay? X to the power of 0 means 1. So, and then we have x to the power of 1, basically it means x. X to the power of 1, it means x. So now we need to find the highest common, what do you call, multiple or what?
It was like high.
So x.
Highest common multiple?
I don't know, like we need to find the highest one, highest valuable that exists in both of them, okay?
The greatest common multiple?
Yes. So as we did with the 6 and 12. So that was the greatest common was 6, yeah? So what is the greatest common multiple in x8 and x2?
2.
Exactly. We have x2 in both of them, so we are going to use x2, right?
Yeah.
X to the power of 2. Now you are going to do y part. So what are you going to use for y?
2.
Exactly, y to the power of 2, because we have that in both of them, right?
Yeah.
Okay. And now we open the parentheses, right?
Mm-hmm.
So for the first part, we put 6 on the outside of the parentheses and x to the power of 8, and we used x to the power of 2. So when we multiply with the inside of the parentheses, it should return back to its original self. So what do we need to multiply x to the power of 2 so that it returns back to the x to the power of 8? So to return 6 back to original 6, we need to multiply it by 1, right? So 6 and 1.
Yeah.
You see here, 6, 1 will make it 6. So we need to write 1 here, but since 1 is just a number, if it's a coefficient of any letter or something or any number, we don't write it because 1 is 1, like 1 Natalie. We don't say 1 Natalie, it's just a Natalie, okay? Or 1 apple,
Yeah.
like we don't, or 1A, 1B, it's just 1, okay? So we don't write if there is something existing near. But if it's alone, then we need to write 1. But when it's alone, if we don't write it, we will think about it as a 0, but it's not 0, okay?
Yeah.
So 1, and then for x, what shall we write? So x2's friend is x6. Here we need to write x to the power of 6, right?
Uh-huh.
And y2?
Y to the power of
1.
1. Oh yeah. Okay. Yeah,
So
now it makes sense now.
y2, you multiply it by 1, you get y2, right? So we write 1 here. And then plus, so again, when we multiply the what's in front of the parentheses with inside, it should return back to the original. Okay,
Mm-hmm.
so we need to multiply x with something, and it should give us 12. What shall we multiply it with? What do you think? What number? 6. Friend of 6 is 2, right?
Yeah.
Here. So we write here 2. And then x square. What's the friend of x square?
X squared 1.
1? Yes. Okay. So 2 multiplied by 1, because if we don't write 1 there, multiplication, we will later assume it as 2 and 1. Okay, so and then y square.
Yeah.
What's the friend of y square here?
Y squared, Y squared, Y squared, Y squared.
What do we multiply y square and then we get y square?
1.
What do we multiply it?
Wait.
1?
No. Not
Yeah.
1, 2.
1, it is 1. When we multiply
what?
something with 1, we get itself, not double or something.
Oh, okay. Oh.
Yeah, 1y square is y square, that's all. 1x square is x square, that's all. You got it?
Uh-huh.
So again we write here 1, okay? And we close the parentheses. So the final answer is, let me change again. final answer is going to be equals to 6x squared and y squared opening parentheses. Now inside parentheses you write.
Okay. Okay.
Yes.
It would just be 1
You are simplifying it. You should be simplifying it. So when we multiply x squared with 1, what do we get?
Oops, my bad.
We don't need to write 1, yeah? We don't need to write 1. We just can write x squared. That's all, right?
X squared, yeah.
Oh, not square. I'm sorry. X to the power of 6.
Oh.
Why am I saying x squared? Aren't you looking up? We are basically continuing the up equation there.
Yeah.
Okay. Plus?
Plus, that would be like 3, right?
Why 3?
Because there's 1 and then plus 2 times 1 times 1. So that would...
Yes, but first we do multiplication, not addition. And this one belongs to this x, like we have a hidden multiplication here. So we already multiplied it with x to the power of 6, so we don't need to multiply it more. So 2 multiplied 1 by 1 is 2, correct?
Yeah, yeah.
So plus
1. Oh wait, plus 2, right?
Yes.
And then close parentheses. Or do we still need something more?
Close parentheses, that's all. Because you multiply 2 by 1, it's 1.
Yeah.
Okay, so which answer? X squared, y squared, and then x6 plus 2. Let's check. Which answer? C. Yeah, 16C. C. Write down, please.
Yeah.
Okay. Now question number 417.
X interpretation of
So what is 2 here? 2 hectare, yeah?
Yeah.
Do you call it hectare or hectare? What do you call that?
I've never heard of the word before, honestly.
Really?
Yeah.
Oh, in Turkmenistan we use that. Even we used to have some land, and it wasn't exactly a hectare, but it was like half of the hectare. It's GA, it's denoted as GA, and it's 100 meters on each side, like 100 meters length, 100 meters width. So what's the area? What's the area of hectare? Don't Google it. I'm telling you. So 100 meters length and 100 meter width. So let me write it here. I have cleared the previous. I'm sorry for that. So we have something like land here. So the width is 100 meters. It is 1 hectare as far as I know, but don't Google it. The width is 100 meters and the length is 100 meters. So what's the area?
2 100?
Yeah, basically we add each 100, right?
Yeah.
No, we add each 100 like
What?
this, madam. Let me explain. So if we have something like this, like from A to the point B, by the way, this A is not this A, they are not same, okay? This
Okay.
and this are not same. No, they are different things, okay?
Okay.
Because this A means area and this A means point A. So we have B.
Okay.
From A to the B, when we are walking, if we walk on the halfway, we have C, and the distance between A and C is 100 meters.
Uh-huh.
And between C and B is also again 100 meters. So what's total distance between A and B?
200.
Exactly, 200. Is it two-dimensional or one-dimensional?
One-dimensional.
Exactly, it's one-dimensional,
Okay.
okay? Just on you are looking from A to the B and you walk straight. No turning right or left, etc. It's just one-dimensional. But what about this? And meanwhile, let me erase it. So now you see one-dimensional here. Okay, I'm erasing it. I hope you understood the concept because I'm going
Yeah,
to
no worries.
explain the other parts as well. So here we have how many dimensional it's. Is it one dimensional or two dimensional?
Um, it's still one dimension?
Huh?
No? Is it still one dimension?
So let me the thing before we wrote was we started from A and we went to the B, right?
Mm-hmm.
And here we have starting from this point and we let's name each points, okay? K, let me name this point as K, L, M, N, okay?
Uh-huh.
So because I will be naming them when I'm showing. From K to the L, we have one dimension, right?
Mm-hmm.
What about from K to the N?
One
Yes,
dimension.
from K to the N is it from K to the L is one dimension. Let's call it X dimension, okay? The word
Uh-huh.
is it horizontal? Yeah, horizontal dimension, yeah. X
Yeah.
X dimension horizontal. So from K to the N, it is it still the X dimension? Is it still horizontal?
No, it's vertical.
Thank you. It's Y dimension. Are they same X and Y?
Uh, no.
Thank
No.
you. They are different dimensions. How many dimensions do we have here?
Two.
Exactly. We have two dimensions.
Okay.
So if everything is in one dimension, we add it. But if it's two dimension, we multiply it. Why? Because we
Oh.
have hundreds of these 100-meter lines, okay? Hundreds of them.
Uh-huh.
You got it? Like this,
Yeah.
hundreds of them. For each meter we have 100. So what are we going to do? 100 multiplied by 100. What's the area? 100 meter multiplied by
Oh.
100 meter.
Oh. Okay. Okay. I remember what I did wrong now. 1,000 meters.
Yeah. So what's the result?
Um, 1,000 meters. The area? Is
1000.
meters? No? Wait, no. My bad.
How many zeros do we have?
It's 10,000.
Exactly, it's 10,000. We put
Yeah.
like we multiply the numbers first. 1 multiplied by 1. So that's 1. How many
Yeah.
zeros do we have? 1, 2, 3, 4. 4 zeros. So
Yeah.
it is 10,000 meters, right?
Yeah.
No. We also multiply meters as well. Okay? Meter multiplied by meter. So if x is multiplied by x, what do you get? X square, right?
Meter squared.
X square.
Yeah.
So meter multiplied by meter.
Meter squared.
Yes, 10,000 meter squares. Okay. This should be hectare, the area of hectare, and it's GA or HA. I'm not sure. 1 GA equals to 10,000 meter square, because we used to call it hectare, and it's coming from the Russian language, but maybe it's hectare. Let's Google it. 1 hectare equals to yes, square meter. Look, Google. Can you see? 10,000 square meter, okay?
Yeah. Oh, okay.
And is it HA? But I don't know. It should have GA. Yes, it's HA. Symbol HA. You see? SI. Okay.
Yeah.
Hectare means HA. So 10,000 meter square. So where we came. So it means in 1 hectare, it's 2 hectare park. And so 2 means 2 hectare. And X here, so altogether this number, 39, 34, is the total number of trees, right?
Yeah.
So this result is total number of trees, and 2x, it means 2 hectare park area. So x should be the average.
C. Right?
Exact. Oh, it's not total. 2x is total, but it's the average number of trees per hectare in park. Isn't it A?
Oh, okay.
Because we multiplied by 2 to get the total number, 2 hectare park. You got it?
Yeah.
So 17 is A. Do you agree?
Yeah.
Let's check and write down that to your note. Let's check our answers. So we started with 15 or 14? 15, I think.
15.
What's the answer for 15?
Yeah. D.
Delta. That's correct. What's the answer for 16?
C.
What's the answer for 17?
A.
You checked your notebook, right? You read them.
Yes.
Thank you. That's good. And you understood all these 3 questions?
Yes, I did.
Very good. Thank you. And I think time is over, and it's midnight 12 here in Turkey. So if you allow me, can we finish this lesson, please?
Yeah.
Okay, thank you. Enjoy your holiday, Natalie.
Okay, thank you.
Thank you. See you. Bye bye.
See you. Bye.